All right, so I want to find the vertical, horizontal, and slant asymptotes along with the holes if they exist. Okay? So here's the function f of x equals x over x plus 4. All right? So first thing I'm going to do, I'm going to start with the vertical asymptotes. So vertical asymptotes, see if I can find any. Well, to find a vertical asymptote, what do? I think about my 3 steps, okay? Step 1, factor. Step 2, simplify. Step 3, set denominator, the bottom, equal to 0 and solve for x, okay? So factor, can I factor it any? No, we're good. Simplify, can x cancel with that x? No, don't think so. Maybe in magic land, okay? So now all I have to do is step 3, which is set the denominator equal to 0. If I set the denominator equals 0, I get x equals negative 4. This is my vertical asymptote right here, okay? Not too bad. Let's see if we can figure out horizontal asymptotes. So horizontal asymptote. Now, horizontal, it looks like the degree of the numerator, the degree is equal to 1 for the numerator. For the denominator, the degree is equal to 1 also. Both of them have degree 1. Therefore, it's the same. So Bobo Botan eats DC. Eats DC. Exponents are the same. Divide coefficients. What are my coefficients for both of these? It's understood to be a 1. So y equals 1 over 1, which is just 1. Now, you might be asking yourself, how do I know where if I'm finding a vertical asymptote, how do I know it's x equals a number? And then like if I'm trying to do, maybe some horizontal asymptote, how do I know it's y equals some number? Well, here's how I think about it, and it's super goofy, but maybe you'll remember it. When I do a horizontal asymptote, I think, hey, right? So I got h-a-y, so y equals some number. So, hey, y equals some number, right? So, and then whenever a vertical asymptote, it's V.A, and then x equals some number. So maybe it's like vax. I don't know. But this one really works for me. Hey, that's how I figure it out. Now, g of x, give you another example. Because we have a horizontal asymptote, then there's no slant asymptote, right? Slant is only whenever you actually have no horizontal asymptote with the numerator degree 1 greater than the denominator degree. Okay, so there weren't any holes because when we factored, there wasn't anything that would cancel, so that's all we got going on for that first function. Let's try g of x equal x plus 3 over x times x plus 4. Okay, x times x plus 4. Now, when I look at this, all right, I think, is it factored? Well, the numerator looks like it's as factored as it can get, and same with the denominator. If it had been x squared plus 4x, what would you do? You'd GCF and factor it to pull an x out, and you get that right there. Okay, so we don't have to worry about that because it's already factored for us. Now we go to step 3. Set the denominator equal to 0. Set the denominator equal to 0. That means either x equals 0 or x plus 4 equals 0. So this one's already solved. So that's one of my vertical asymptotes. My other one is minus 4 from both sides. I get negative 4 for x. So that is the vertical asymptote right there. X equals 0 and x equals negative 4. Horizontal asymptote. Horizontal asymptote. Well, let's think about it. If I did multiply this through, I would get x squared times 4x, right? Which is a degree 2 in the denominator. The degree in the numerator is just degree 1. So bigger on bottom, Bobo, so O stands for y equal to 0. Okay, hey, y equals 0. Do I have any holes or slant asymptotes? No. All right, can't have a slant asymptote if you have a horizontal asymptote right there, right? Okay, so let's try another one. F of x, no, well, we already used f of x. Let's use h of x equals x over, let's say, x squared minus 3x. Okay, x squared minus 3x. First thing I've got to do for my vertical asymptote, I want to factor. So factor first. If you don't know what you're doing, at least try to factor it. I have x over, x doesn't factor, but in here I can pull an x out of each of these, right? So an x comes out, and what do I have left? I have x minus 3 in here. Now, is there anything that will cancel for me here? Yeah, I think so. This x and this x cancel, and this gets me 1 over x minus 3. Okay, 1 over x minus 3. This automatically tells me when I cancel, when you cancel factors, you get a hole. There's a hole! Okay, there's a hole in the graph. Where's the hole at? You set the factor equal to 0. So there's a hole at x equal to 0. If I plug in x equals 0, it blows up. You get 0 divided by 0. Okay, there's a hole. Now, once I factor and I cancel, then I set the denominator equal to 0. I get x equals 3. That is my one vertical asymptote. If you did not cancel these, then you might be tempted to think that x equals 0 and x equal 3 are both vertical asymptotes. But since they cancel each other, then you know that there's a hole at that and it's not actually a vertical asymptote. Okay? Horizontal asymptote. So HA, horizontal asymptote. Hey, right? The numerator degree, all right? The numerator degree is 1. The denominator degree is 2. Squared term, linear x term. Okay, bigger on bottom, bobo, that's y equals 0. Y equals 0. But I do have a hole at x equal to 0. All right, I have a hole at x equal to 0. Now, technically, it's a location, but if you get x equal to 0, I'm good with that. So technically, if you want to get technical, it's 0, comma, and then you plug in here. You plug in a 0, and you get 1 over 0 minus 3, which is 1 over negative 3. So technically, this is where the hole is located. But, you know, like I said, if you get this, I'm happy as a bump on a log, right? Okay, so just to give you an idea of what this graph sort of looks like, let's graph it. Okay, let's graph it. Let me delete this. So what we had? We had x divided by parentheses x squared, x squared, and then I think it was minus 3x, maybe? 3x, close parentheses, enter. Let me make sure that that's right. Okay, x, all right, cool. Oh my goodness. Wrong way. All right. So when I graph it, it looks like this. Now, there is an issue, right? There's an issue here because technically there's a hole in my graph at x equals 0, okay? So really, what did we say? When we reduced it, we had h of x equals 1 over x minus 3. This is true as long as x is not equal to 0. If x equals 0, then that thing falls apart, right? So if I was graphing it, I know there's a vertical asymptote where. Well, I did red here because I want x equal to 3, vertical asymptote. I want you to think of red as kind of like a stop sign, okay? So like a red light, you don't ever run red lights, right? Okay, so we don't ever run red lights. That's right. Okay, so we never cross this red light here, okay? So when I plug in values that are a little bit bigger than 3, so maybe like 4, so x equal to 4, so that'd be like 1 over 4 minus 3, that gets to 1 over 1, so it's positive, so I can put a dot here. I know I'm going to be up on this side over here, and then I'm coming down just like that over there. Okay, if I plug in something a little bit smaller than 3, so like maybe 2, so that's like 1 over 2 minus 3, which is negative 1. So that's like down here. Now, what do I know about this graph? I have horizontal asymptote at y equal to 0. Okay. So we're getting really, really close to y equals 0 at infinity. Okay, but we're not getting there. Now, I could put orange for my horizontal asymptote, which really, I guess yellow might be better. Why yellow? It's kind of an orange light or a yellow light. Sometimes we speed and we pass through the yellow light, and sometimes we don't, right? So for this particular one, the graph does not cross the horizontal, but that's not always the case. Sometimes you'll have a scenario where it crosses the horizontal, it crosses back, it crosses, and then eventually it levels out like it's supposed to, okay? But with a vertical, a red light, we never run a red light. So we never cross verticals for rational functions, okay? But sometimes you might cross a horizontal asymptote. All right, so that's how that graph looks, except we have a hole. Where's our hole? Our hole is at x equal to 0. So that means right here at x equals 0, we have a little hole there. So I'm going to be expecting you to tell me at x equals 0, there's a hole. So you better put a little circle there in your graph. Okay. All right. I hope that that was beneficial to you. All right, let me zoom out so you can kind of see that whole problem just taken at 1 point. All right, cool.